Hello class, this is the next set of examples for solving using the double angle identities. You can pause the video and give this a go, but let's go solve them now. You'll find that actually using the identities isn't so difficult. It's the equation solving part that's rather difficult here. So since we have sine of 2x, we can see what our value of a is. Using our identity for sine 2a, we should get 2 sine x cos x minus cos x is equal to 0. So that's just using the identity. Hope you find that it's not too difficult. But when it comes to solving this, we should be using our trig solving skills. It's no different as before. For this, if you try and divide by cosine, you actually might lose out on some factors. So it's best if you can factor first. So by factoring, we get cos x outside of 2 sine x minus 1. Hope you can see we can take out that common factor equals 0. And we solve this as we would using the zero product rule, so like as if it were a quadratic. So we get cos x is equal to 0, x is equal to cos inverse of 0, and from here you should use your calculator, or if you can recall your unit circle, you should get 90 degrees and 270 degrees, which if we convert into radians, that's going to be pi on 2 and 3 pi on 2. Same deal for this other factor. I'm going to move the negative 1 straight away, so we get sine x is equal to positive 1 dividing by 2 and taking the inverse, so sine inverse of half. I did two things in one go. Sine inverse of half, you should be getting, I believe it's going to be 60, but we should always check. Sine of half, that's actually 30 degrees, but that's just in the first quadrant. Remember, if it's positive and it's in the entire domain from 0 to 360 or 2 pi, we also need to take into consideration the other quadrants. Sine is positive, so it can be positive half in the second quadrant as well, which is 180 minus 30. That's nice and simple. It's going to be 150 degrees. Converting to radians, 30 divided by 180, we get pi on 6. And 150 divided by 180 should get 5 pi on 6. There's how we solve this trigonometric equation by using the double angle identity of sine. You can go ahead and pause the video and try this yourself. As you can see, we're going to be needing to use cosine 2a. So we have the value of a here being x. Using this identity, hope you can see it's not too difficult. We should be getting cos squared x minus sine squared x minus cos x is equal to 0. Now it may seem not obvious what to do from this point, but since everything is so close to cosine, we should convert this also in terms of cosine. I'm going to be using my identity here, sine squared x plus cos squared x is equal to 1. Moving this to the other side, we get negative cosine squared. So this becomes cos squared x minus sine squared is this identity here, so 1 minus cos squared x minus cos x is equal to 0. continuing this, let's move this out of the way. Let's expand this. We get cos squared x minus 1. Expanding that, we get plus cos squared x minus cos. These two are like terms. We get 2 cos squared x minus cos x minus 1 is equal to 0. Now it may not seem obvious, but you can almost look at this as if it were a quadratic. Take a look. You get 2u squared minus u minus 1 equals 0. Hope you can see that. So we let u be cosine. U squared is cosine squared. So we can solve this one to factorize this. Factorizing by grouping. So we need two numbers that multiply to -2 but add to -1. So two numbers that multiply to -2 but add to -1. I'm thinking positive 1u minus 2u minus 1. Let's move this around. So these are the two numbers. If you take a look, -2 and 1 multiply to -1. -2 plus 1 is -1. So that's what we're looking for. So 2u outside of u minus 1 plus u minus 1. Factoring this, so that there is the factorization that I was looking for. Resubstituting u, we get cos x minus 1, 2 cos x minus 1 equals 0. Let's make some more space for myself. And solving each one individually as we did before. Cos x is equal to 1, so moving this to the other side of 0. X is equal to inverse of cos of 1. And I hope you can see that we should get x should equal 0 and 2 pi. Solving this, we get 2 cos x equals 1, so moving this over to the other side of 0. Dividing by 2 and taking the inverse of cos. So cos inverse of half. Cos of half, going back to our triangle, 60, 30, 3, 1, 2. Half is adjacent over hypotenuse, so that's 60 degrees. 60 degrees is pi on 3, but we also need it in the fourth quadrant. So 360 minus 60 degrees is 300 degrees, but we need to convert that into radians. So we should be getting 5 pi on 3. So our four answers to this are x is equal to 0, pi on 3, 5 pi on 3, and 2 pi. So I hope that gave you an insight into trigonometric equations, but more so how we could apply these trig identities to solve these trig equations. Hope to see you in the next video where we tackle these last two examples. Hope to see you then. Best of luck.